We stand at the edge of a new cosmic dawn. For thousands of years, humanity has looked up at the night sky, filled with wonder and asking the biggest questions of all. Where did we come from? Are we alone in this vast, dark expanse? Today, on this remarkable day, June 13th, 2026, we are closer than ever to finding some answers. A new eye has opened, pointed towards the heavens. This eye is the James Webb Space Telescope, a magnificent machine built by human hands, now ready to begin its epic journey of discovery. It represents the culmination of decades of dreams, engineering, and the relentless human desire to explore the unknown. The air in control rooms around the world is thick with anticipation. Scientists, engineers, and dreamers hold their breath, their eyes fixed on screens displaying streams of data. This isn't just another mission, it is a leap into a new era of astronomy. The Webb telescope is not merely an upgrade to what has come before. It is a revolutionary instrument designed to see the universe in a way we never could until now. It will peer back in time, to the very first light that ignited after the Big Bang, and it will scan the atmospheres of distant worlds, searching for the telltale signs of life. The excitement is palpable because today we are all explorers. Think about the moment Galileo first pointed his simple telescope at Jupiter and saw its moons. In that instant, our view of the universe and our place within it changed forever. We realized we were not the center of everything. The James Webb Space Telescope promises a similar revolution, but on an even grander scale. It will show us things we have only ever imagined and reveal wonders we cannot yet conceive. This is more than just science. It is a profound part of the human story. It's a story of curiosity, of reaching out beyond our small world to touch the fabric of the cosmos itself. As Webb locks onto its very first target, we are embarking on a shared adventure. We are taking the next step in a journey that began when our ancestors first followed the patterns of the stars. The images and data that will soon stream back to Earth will belong to everyone. They will fill textbooks, inspire art, and fuel the imaginations of the next generation of scientists and explorers. We are about to see the universe in a completely new light, and we will all get to witness it together. The story of the cosmos is our story, and a new chapter is about to be written. So, what exactly is this incredible machine? The James Webb Space Telescope is the most powerful and complex space observatory ever built. You can think of it as a giant golden eye designed to see what our human eyes cannot. Its primary mirror is enormous, over 6 meters across, and composed of 18 hexagonal segments coated in a thin layer of pure gold. This isn't for decoration. Gold is exceptionally good at reflecting infrared light, which is the key to Webb's power. This mirror is a work of art and a marvel of engineering, folded up like origami to fit inside a rocket, and now unfurled 1,000,000 miles from Earth. Unlike the Hubble Space Telescope, which orbits relatively close to Earth, Webb is positioned far out in space at a special point called the second Lagrange point, or L2. This distant location keeps it shielded from the heat and light of the Earth and the Sun. To see the faint, infrared glow of distant objects, the telescope must be incredibly cold, colder than any freezer on Earth. It carries a massive 5-layer sunshield, the size of a tennis court, which acts like a giant parasol. This shield blocks out the sun's energy, allowing the telescope to cool down to a frigid -233 degrees Celsius. The reason Webb needs to be so cold and see in infrared is simple. The universe is expanding. As light from the earliest stars and galaxies travels across billions of years to reach us, it gets stretched out. Visible light shifts into longer, invisible wavelengths, becoming infrared light, which we perceive as heat. Webb is essentially a time machine. By capturing this ancient infrared light, it can see the universe as it was more than 13.5 billion years ago. It will witness the birth of the very first galaxies, shining out from the cosmic darkness of the early universe. This telescope is a testament to human ingenuity. Its creation involved thousands of scientists and engineers from all over the world, working together for decades. It is a floating laboratory equipped with 4 highly advanced scientific instruments. These instruments are not just cameras. They are sophisticated tools that can split light into its component colors, a technique called spectroscopy. This allows scientists to determine what distant stars, planets, and galaxies are made of, their temperature, and how they are moving. We have sent our most advanced senses into the void to observe the universe in breathtaking detail. Every great journey begins with a single step. For the James Webb Space Telescope, that first step is to point its golden mirror towards a carefully chosen target. NASA has selected a region of space known as a stellar nursery, a place where new stars are being born. This first target is a vast, swirling cloud of gas and dust within our own Milky Way galaxy. These nebulae are among the most beautiful and dynamic objects in the cosmos. They are cosmic cradles, where gravity slowly pulls together massive clouds of material until they collapse under their own weight and ignite, forming brilliant new stars. Why start here? Because Webb is uniquely suited to peer through the dense dust that shrouds these stellar nurseries. To our eyes, and even to telescopes like Hubble, these regions can appear dark and opaque. The dust blocks visible light, hiding the incredible processes happening within. But infrared light can pass straight through the dust, much like X-rays can pass through skin to reveal the bones underneath. By looking in the infrared, Webb will be able to lift the cosmic veil and reveal the newborn stars hidden inside. It will give us an unprecedented view of star formation in action. This first target isn't just about seeing something new, it's about understanding our own origins. The Sun, our star, was born in a similar cloud of gas and dust about 4.6 billion years ago. The very elements that make up our planet, and even our bodies, were forged inside stars that lived and died long ago. By studying the birth of other stars, we are essentially looking at a snapshot of our own solar system's distant past. We will learn more about the physical processes that lead to the formation of not just stars, but also the planets that orbit them. This makes the choice of target both scientifically brilliant and deeply personal. As the first data is collected, scientists will be calibrating the instruments, ensuring everything is working perfectly. But they will also be looking for the first signs of protostars, infant stars that are still gathering mass from their parent cloud. They will be looking for the disks of gas and dust that surround these young stars, the very places where new planets might be forming. This first observation is a test, but it is also a promise. It is the promise of seeing the universe's creative process with a clarity we have never had before, connecting us directly to the great cycle of cosmic birth and death. What will these first images actually look like? Prepare to be astonished. The images from the James Webb Space Telescope will be unlike anything we have ever seen. While we can't see infrared light with our eyes, scientists will translate this data into stunning, colorful pictures. The different colors in the images will represent different wavelengths of infrared light, each telling a different story about the object being observed. We can expect to see vibrant portraits of the cosmos, painted in a palette of light that has been traveling across the universe for millions, or even billions of years. Imagine seeing the first target, the stellar nursery, come into focus. We will likely see ethereal wisps of glowing gas, illuminated from within by the intense radiation of newborn stars. These clouds will be rendered in brilliant shades of red, orange, and gold, representing the different temperatures and densities of the material. Piercing through the dust, we will see the pinpoint lights of newly formed stars, some still wrapped in their dusty cocoons. We might even see jets of material being blasted out into space by these young stars, spectacular fireworks celebrating their violent birth. It will be a dynamic and breathtaking scene. Beyond this first target, Webb will turn its gaze to the wider universe. It will capture images of distant galaxies, so far away that we are seeing them as they were in their infancy. These will not be the well-defined spiral and elliptical galaxies we see nearby. Instead, they will likely be smaller, clumpy, and irregular, the first building blocks of the grand structures that fill our universe today. Seeing these primordial galaxies will be like looking at the first few sentences in the epic story of the cosmos, helping us piece together how everything we see today came to be. The beauty of these images will be more than just aesthetic. Each pixel will contain a wealth of scientific information. The colors will tell us about the chemical composition of stars and galaxies, revealing the presence of elements like hydrogen, oxygen, and carbon. The shapes and structures will tell us about gravity, dark matter, and the fundamental forces that govern the universe. For scientists, these images will be treasure maps, guiding them to new discoveries. For the rest of us, they will be windows into a universe more wonderful and complex than we could have ever imagined. Perhaps the most exciting and profound part of Webb's mission is its ability to study planets orbiting other stars, known as exoplanets. For centuries, these other worlds were purely the stuff of science fiction. Now, we know of thousands of them, and the James Webb Space Telescope is poised to study them in unprecedented detail. This brings us tantalizingly close to answering the ultimate question: are we alone? Webb won't be able to take a direct picture of an alien city, but it can search for the chemical fingerprints of life in the atmospheres of these distant worlds. The telescope will do this using a clever technique. When an exoplanet passes in front of its host star from our point of view, a tiny fraction of the starlight filters through the planet's atmosphere. Webb's sensitive instruments can capture this light and analyze it. Different gases in the atmosphere absorb specific wavelengths of light, leaving a unique barcode-like pattern. By reading this pattern, scientists can determine what the planet's atmosphere is made of. They will be looking for gases like water vapor, methane, and oxygen, gases that, on Earth, are associated with biological processes. Imagine the moment we detect a compelling combination of these gases around a rocky planet in its star's habitable zone, the region where conditions might be just right for liquid water to exist. It wouldn't be definitive proof of aliens, but it would be the most profound discovery in the history of science. It would transform our understanding of our place in the universe. The knowledge that life might be common in the cosmos would change everything. The weight of that possibility rests on the data that Webb will send back, bit by bit, from across the vastness of space. In control rooms and laboratories, the mood will be one of intense focus and quiet hope. As the spectrographic data from a distant world appears on a screen, scientists will work to decode its message. Every peak and trough in the graph could hold a clue. The people watching are not just doing a job, they are on a quest. They are the proxies for all of humanity, peering into the darkness and listening for a whisper that says, "We are not the only ones to look up at the stars and wonder." Webb's search for habitable worlds is a search for ourselves, for our cosmic family. As the James Webb Space Telescope begins its long watch, we are reminded of how small we are, and yet how much we can achieve. From a small blue planet in a quiet corner of the Milky Way, we have reached out to touch the dawn of time. This telescope is more than a collection of mirrors and sensors. It is a symbol of human curiosity, collaboration, and our unyielding drive to understand. It is the embodiment of our desire to know our place in the universe. The discoveries that await us will not only fill our textbooks, but will also shape our philosophy and our perspective on life itself. This journey is just beginning. Over the next decade and beyond, Webb will rewrite our understanding of the cosmos. It will uncover new mysteries even as it solves old ones, pushing the boundaries of our knowledge ever further. The images it sends back will inspire a new generation to look up at the sky, not just with wonder, but with the understanding that they too can be part of this great exploration. The story of the universe is far from over, and we are now equipped to read its earliest and most distant chapters. This is a legacy for all future generations. Looking at an image of Earth from space, you see a world without borders, a single, fragile home for all of humanity. In the same way, the discoveries of the Webb telescope belong to everyone. They remind us that we share a common origin, forged in the hearts of stars, and that we may share a common destiny as explorers of the cosmos. In a world often divided, the quest for knowledge about the universe has the power to unite us. It gives us a grander perspective, showing us that our shared curiosity is more powerful than our differences. So, as we look forward to the first light from Webb, let us do so with a sense of hope and unity. We are living in a privileged moment in history, a time when we can witness the universe revealing its deepest secrets. The journey ahead will be long, filled with challenges and breathtaking revelations. but it is a journey we take together, as a single species on a remarkable adventure. We are stardust, and we are finally learning to read the story of the stars from which we came. The universe is waiting, and we are ready to see.